Good morning. Just sharing the link, 1 minute. I'm fine, thank you. Good morning. आज क्यों करी रही है? आज क्या स्पेशल है? Hi Ovian. Good morning everyone. Chalo start the class please. So today I plan to what you call start the classes early, but thunders was there and it was like good morning Gopika. Good morning everyone. So quickly informing the group that class started. Auntie started the class please. Oh, super. Sneha came today. Wow, Sneha, what a pleasant surprise for you. Sorry, for me. How can it be pleasant surprise for you? It's a very pleasant surprise for me. Sneha is coming in morning class. Kritika, good morning. Good morning, Sophia. Good morning, Sarvana. Good morning, everyone. Come on, come on, come on. Send in the group. Class started. Inform everyone that class started. Inform everyone, class started. Okay. First work is yes. Good morning, Ashwita. So shall we start the class, please? Ready, everyone? See, last class we were discussing about we have discussed about carboxylic, we have discussed about aldehyde, we have discussed about alcohol, we have discussed about ether. Ether we have discussed or not? Alcohol we have discussed, ketone we have discussed, carboxylic we have discussed, ester we have discussed. Okay, this much we have finished. Now we are what we are going to do is we are going to study. Yes, no, ether we have not discussed. Na? Yes, I think same. We have not discussed ether, so we are going to discuss ether also. So today we are going to discuss ether first. Good morning, everyone. Yes, thank you so much. So please kindly join the session as fast as possible. Yes, ether not started. Yes, absolutely. Good morning, Mahalakshmi. It's nice to see my children together, and definitely evening also I'm going to keep class for you. What should I do in home? You say. So what I'm going to do is, thank you so much for liking the class. Good morning, Durga. Okay. So we'll start the session first. So first give a heading ether and try to understand in ether what and all we are writing. Okay. So first work is good morning. So now look here. Ether when you are starting with E-T-H-E-R. Ether. Understood? So in the ether part, what we are going to understand here is, thank you for liking the class. So now look here. General formula. What can be the general formula for ether? General formula. So when we are talking about the general formula for ether, the general formula for ether is RCO. Check this one out. RCO. Is it correct? Everyone, come on, say. Good morning, Illusion. Is it correct for ether? The answer is Anjit. Okay, beta, we are going to talk about carbon. We are exactly doing what? We are exactly studying the ether part. If you see the previous part of the videos, we have already finished. So now here it is O R dash. This is about ether. Okay. So this is about ether, and that ether part we are going to solve. So what is exactly we are going to talk it as prefix in ether. We are going to put prefix. See if it is related to study means you can ask. So now look here. What is exactly for the prefix section? Please kindly note down for prefix section alkoxy. We say alkoxy. What we are saying? Alkoxy. What we are saying it as alkoxy. This part is called as alkoxy, and IUPAC name is alkyl alkoxy. Okay. So what is the question? Please kindly ask. Alkyl alkoxy. What is exactly it is? Alkyl alkoxy. Alkyl alkoxy. Question please. Ask please. So alkyl alkoxy, everyone please kindly pay attention. IUPAC name will be alkyl alkoxy. Alkyl alkoxy, like methyl methoxy, ethyl ethoxy, propyl propoxy, like that we are going to call it as. Okay. Now here question. Okay, so here when you will be writing about, first you need to give importance, preference will be exactly given. So now we are going to write some of the names. Now look here, if it is given as CH3O C2H5, okay, CH3O C2H5, CH3O, मुझे नहीं पता. So now look here. So how to write the name, beta? Can you exactly say this? Everyone, come on, start this and tell me that. Check you are live or not, everyone. Now check and start answering the question. It will be what? How we are going to call it as? Methyl methoxy. I think alkyl alkoxy. No, alkoxy alkane. तुम्हारे क्वेश्चन के चक्कर में alkoxy alkane. Okay, so here it is exactly, no, I don't know about that person. So alkoxy alkane. So what is the answer we are going to say here? Now please check this one out. So methoxyethane, when we will be writing it, how we are going to write it as methoxyethane. How we are going to write it as methoxyethane. Okay, so how we are going to say methoxyethane. Methoxyethane. How it is? Methoxyethane. Methoxyethane. Got it? Now next one, if you are writing, please check this one out. So we will be writing C2H5O C2H5. Come on, name this. Children, try this one out. C2H5. No. C2H5 and C2H5. Come on, name this. C2H5, C2H5. Try, name this. Methoxyethane, correct. Pratika, correct. But we need to check that you are live or not, because the answers are coming very late. So only I am asking. So if CH3O C2H5, when it is there, how we are going to write it as? Come on, say. Methoxyethane, that's the previous answer you have given. Now please kindly give the answer now. Is it C2H5O C2H5? It's the very easy one. Ethoxyethane, absolutely correct. It will become ethoxyethane. It is exactly coming as what? Ethoxyethane. What it is coming as? Ethoxyethane. Ethoxyethane is the correct answer. Yes, ethoxyethane. Ethoxyethane is absolutely correct answer. Yes, say. Ethoxyethane is correct answer. Now we are going to go for next one. Done. The next question is, come on, check this one out. CH3, CH2, CH3, CH2, CH, CH3, okay? And here, this part is connected with O and then CH3. Come on, try this one out. Now say, hey, everyone, come on, say me good morning fast. Good morning. Yes, 100% बढ़िया. See, only these many children are saying good morning. Where are the rest of the children? They said good morning and they slept, huh? Ah, very nice, super. I am only idiot. Okay, fine. We'll start the class. Only five people are visible, so only I'm worried about. Come on, everyone. Dimethoxy. A dimethoxy, how it is coming there? Huh? Dimethoxy, how it is going to come? Yes. Where is Neha? Good morning, Anu. Dimethoxy. Dimethoxy will not be there. What is the location? What is the location where it is added? See, when basically it is added, you need to check the location. Okay, butoxy 3 methyl. Good morning. See, look here. This is exactly not the correct way of approach. Please check this one more time and try and understand this one. Okay. So what is exactly given here is, here this is location 1 and this is location 2. So in 2 location only it is connected with methane. Understood? So here when in 2 location it is connected with methane, how we are going to name it? That's the most important thing. So naming part will be coming as 2-methoxy butane. It is exactly coming as 2-methoxybutane. 2-methoxybutane. It is coming as 2-methoxybutane. What is the perfect way? 2-methoxybutane. How we are going to call it as 2-methoxybutane. I hope you might have understood this one. So it is exactly going to be called as 2-methoxybutane. Now next is C2H5O, C2H5O and C3H7. Come on, say name. Say name. C2H5O and C3H7. Which one is going to be taken? Name. So now how we are going to tell fast? Come on, try. Satya, good morning. O2, huh? Oxygen. CO2, carbon dioxide. So ethoxypropane, absolutely. This is exactly called as what? Ethoxypropane. Absolutely correct. Propane. Ethoxypropane. Little bit thunders are here. So what you called the network is going here and there. Zinc. So this is exactly going to be, I hope you might have understood this one. So this is ether. In ether, alkoxy is the prefix. Prefix means which comes first is the prefix. Okay. Okay, exactly. This is when you will be writing this part. So you need to understand that when you start this part, ethoxypropane, methoxypropane, like that. When you are writing, you need to write that in this format only. Okay. I hope you might have understood this section. Network. Okay. So now we are going to go for haloalkanes, alkanes family. Okay. So sometimes we are exactly going to deal with alkanes family. Alkanes family. So when we are talking about alkanes family, yes, elevation, alkanes family, when we are talking about, so that time how we are going to interact and talk about halogen. Halogen we have, yes, that is the halogen. Group 17 will be there. They will be considered as what? Halogen. Okay. Okay, halogen family, and that is exactly when we were talking about haloalkanes. Haloalkanes means chlorine, bromine, iodine, fluorine will be there, but fluorine structure is very small, and what you call HF means its combination. Yes, its combination is little bit difficult. So what we are doing is, hi M, Kavya, good morning. So how we are going to start that with? Come on, check this one out. Rx we are going to say, not RDX. Okay, Rx. So when we will be talking about chlorine, bromine, iodine. Okay, so they really need someone to join about. Yes, good morning, Veda. So when, yes, chlorine, bromine, iodine. So when you will be talking about chlorine, bromine and iodine, the combination of this with chlorine, bromine, iodine will be there. But how we are going to call it as? Okay. So CH3Cl. It is called as chloromethane. Methyl is there now, but here we are not going to call it as methyl. Why we are going to call it as chloromethane. We are going to call it as CHLORO, chloromethane. What we are going to call it as? Chloromethane. Understood? Bye bye. So it is exactly called as what? Chloromethane. When we are going to write for bromine, so it is exactly C2CH3, then it is called as bromomethane. And with iodine it is called as iodo. With iodine it is called as iodomethane. Iodomethane. So when it will be combined with CH3, it will be called as iodomethane. Absolutely correct. When it will be combined like this, yes, bromomethane, bromoethane, iodo, bromo, chloro, bromo, like that we are going to say. So whenever you will be joining it with any other, then time we are going to call it as like that name only. I hope you might have understood this one. Yes, iodomethane. So if it will be combining like this, come on, check this one out. C2H5Cl. Come on, name this. C2H5Cl. Come on, name this, everyone. C2H5Cl. Anyone who wants to name this? C2H5Cl. Chloromethane. This is not chloromethane. Answers are coming little late because you are not live. So only when you are responding, it is exactly chloroethane. Absolute. This is exactly called as what? CHLORO, chloroethane. Absolutely correct. This is considered as chloroethane. Thank you for liking the classes. So now this is exactly called as what? Chloroethane. Thank you so much, beta. This is considered as chloroethane. Okay, so chloroethane, this will be the part. Okay, now this exactly some part of it we have done. The most important sections we have, yes, because 2 carbon is there, so absolutely. So if 2 carbon will be, thank you so much. So 2 carbon will be there, so it is called as chloro. Absolutely correct. I hope everyone's class, schools are exactly now, holidays are there, so definitely we will be studying more. So chloro part, where is Jotam? Jotam, where are you? So this is exactly chloro section. Okay. Now we are going to go with some. We are going to go with some naming, some very complex naming. We are going to check. Chloroethane, absolutely correct. I want everybody to type and say the answer, and I will call out your name, and you have to answer my question. Electricity numerical. Electricity numericals also we are going to start today. Most probably, I think evening time only I am going to take class. If it is a heavy rain means, Smriti, good morning. So if it is a heavy rain means we are going to start in the evening section. Okay, online only I am going to teach today because going Triple Kundram is slightly not possible. Rain is very heavy. So now look here. Can you tell me the name of this? Most probably live stream only we are going to take. Come on, come on, come on, come on. Try the name of this. Good morning, Smriti. Come on, try out this one. Come on. See the type of respect you people are giving. They have been means. Come on, come on, come on, come on, say. They have been means I don't know. Cyclohexane. Super. It is not hexane. If you will be seeing here, no idea. So here, can you check one thing, everyone? It is not O is there. How can you say hexane? How it can be? How can you say it is hexane? Hexane is not possible. Uh-uh. Hexane is not possible. No, 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 no. The try is exactly not working. The try is not working. Hexane is not going to come. Come on, tell next one. Try. This is called as cyclo. Cyclo is absolutely correct. Hexane part 6 is there. Lipase. That is not lipase, okay. So this is called as cyclo. Hexanon. Cyclohexanon. N-O-N-E. Hexanon. Cyclohexanon. What it is called as? Cyclohexanon. 6 is there now. So it is considered as cyclohexanon. Yes. That is exactly called as cyclopentane is not there. It is cyclohexanon. It is called as what? Cyclohexanon. Cyclohexanon. Absolutely. So this is exactly called as, repeat with me. This is exactly called as cyclohexanon. This is exactly called as what? Cyclohexanon. Okay? Cyclohexanon. I hope you might have understood. So this is considered as cyclohexanon. Absolute. Super. Cyclohexanon. Good. Cyclohexanon. Now we are going to understand some most important sections. Now please pay attention. So we have to understand, we are going in the next part. Now what is the meaning of combustion? Can you tell me? So now chemical reactions in organic compound, notes will be available to you. So notes will be available to you, but we are going to understand some of the most important sections. So get ready for it. So, yes, we are going to understand this part. Yes, fire. Combustion means fire. Was super answer. Combustion means fire. Combustion means fire. That's absolutely correct. Combustion means fire. That's no doubt about it. But in combustion, how we are going to call combustion in organic chemistry? That part I want to understand from you. Yes, fire. Combustion means fire. Burning in presence of oxygen. Yes, absolutely. So anything which burns in presence of oxygen is considered as combustion. That's true. Very good. So now combustion of carbon is exactly in the presence of sufficient amount of oxygen. Combustion of carbon. So what we are going to do, we will be talking about, the next section is types of chemical reaction in organic compound. Types of chemical reaction in OC. Types of chemical reactions in OC. Yes, so you need to understand that carbon is element. Okay, so definitely we need to understand one thing, that see, whenever we talk about carbon, we know one thing is, like, carbon is present everywhere. It is exactly present in all sorts of things. So whenever we talk about the presence of carbon, though carbon amount is very less, its presence is very high. So if somebody will be asking you, burning in presence of oxygen and produces heat and light, and it is exothermic reaction, absolutely. Oxygen fuel, does it present in pizza? Carbon dioxide will be there, because of that holes will be there, that is in cake. Okay. Everyone, please pay attention. Learn this section very carefully. Try and understand this part very carefully. Understand this. So, most important thing is ki combustion. So, first we are going to study chemical properties of carbon compounds. So, carbon compounds chemical property we are going to understand. In that, the reactions we are going to discuss. In that reactions, how we are going to discuss it as, the first part is ki burning in presence of oxygen and produces heat and light. Okay, and it's exothermic reaction, absolutely correct. So now, like carbon, when it will be burned in presence of oxygen, it is exactly giving carbon dioxide. Carbon burning in presence of oxygen, carbon burning in presence of oxygen. So when it is exactly producing carbon dioxide with presence of heat and light. So here heat and light is also. So because Kavya you have given, so I'm just going to add that yes, it is true. It is exactly going to produce heat and light. So this is exactly the definition of combustion. Given anything, yes, when anything is burning, in presence of oxygen, sufficient amount of oxygen. See, If sufficient amount of oxygen will not be there, then rather than making carbon, that is not O2 up, CO2, yes, then rather than making carbon dioxide, it will make carbon monoxide. Okay, so oxygen sufficiency is needed. What is needed? Oxygen sufficiency is needed. Oxygen must be present in sufficient amount. Understood? Oxygen must be present in sufficient amount. That's what is exactly called. Understood? Yes, so carbon dioxide is there. Carbon dioxide is there. So carbon dioxide is after complete combustion. Carbon dioxide gas will be produced, ashes will be there, and with heat and light. So that time it is called as combustion. Now we will talk about methane. So now let's see methane. CH4, methane is burned. Okay, so when methane is usually a gas, it will be burned in presence of oxygen. Come on, so I'm just writing the balance equation. When methane we are going to burn in presence of oxygen, what it is exactly making is carbon dioxide and 2H2O, carbon dioxide and 2H2O plus heat and light, and this is for Kavya, plus heat and light. So here Kavya has told about, yes, it is a combination combustion process, produces water and carbon dioxide. Absolutely correct. Water, carbon dioxide with heat and light. Absolutely correct, Anu. So this is exactly called as combustion reaction. Okay. Now we need to understand certain factors related to combustion. Okay, water, carbon dioxide, heat and light. Absolutely correct. I hope everybody must answer. You know what? When you are in the process of study now, one thing I'll tell you: 122 days are left for board examination. First factor. Second factor is 122 days will go like this. Third factor, it's me. Always think about like that. See, it's about me and I can do it. It's not impossible, it's possible, because my logo is always nothing is impossible. So when you will have this attitude, definitely you will start rock and roll. The rock and roll will come. एरर हो रहा है कहाँ से? मेरे साइड से. ओके, कोई बात नहीं, check कर लो. So understand this part. So whenever this part contents are there, so I want everybody, please understand this one, that please kindly start delivering the best answers and think that this is your race. Huh? Are you all ready? Are you all ready? Now one content I am going to ask from all of you. Yes, open. Was super Ovian. And that's what the sign now, Ovian. We need to understand this. 80 out of 80 should be target. Why should I be thinking about 60? Why should I be thinking about 70? I should be thinking about 80 out of 80. Dream big. Yes, dream big and dream grand. And I am there with you, yaar. We are going to study day and night. What is there? We are going to study day and night, and we will not leave one single question before examination. So attitude should be this, and attitude should be, I'm not weak, I am the strength. About 27. Okay, fine. Now look here. Now we are going to understand some very important thing, like saturated hydrocarbon. If somebody will be asking you about saturated hydrocarbon, so it is giving you a clean flame. Okay, so saturated hydrocarbon, we are going to talk about saturated hydrocarbon. When someone is talking about saturated hydrocarbon, so saturated, what you are saying, Anu, for chemistry, only textbook equation will come for board exams. No, don't think like that. The first thing is, ki mostly NCRT questions are the mantra. Okay, you need to do that part. First, you need to finish. Okay, and another thing is ki we must prepare for all. See, that equations are most important, that I am not denying. Okay, that equations are most important, but you need to understand one thing: extra content, extra thing related to that also we will be studying. Okay. Okay, Anushri, it's not you. Okay, fine, no problem. Yeah, anyone can answer. Anyone can ask. So first, beta, we are going to talk about saturated hydrocarbon. So if somebody will be asking you about saturated hydrocarbon, So when saturated hydrocarbon we are talking about, please understand this section. In saturated hydrocarbon, generally it will be exactly burning with a clean flame. Double bond and triple bond is not there in saturated hydrocarbon, first thing. And another important thing is कि unsaturated hydrocarbon will be giving what type of flame? Unsaturated hydrocarbon will give what type of flame, beta? It will give you a yellow flame. It will give you what type of flame? Yellow flame. Unsaturated hydrocarbon. Saturated hydrocarbon, blue flame or clean flame. One we are talking about, we can say like that. Unsaturated hydrocarbon will be giving a yellow flame. Absolutely correct. It will be giving what color flame? Yellow flame. Next important part we are going to talk about. Okay, triple bond, double bond, both you are going to take now. And black smokes will also be there, and they will be releasing lots of black smokes, beta. They will be releasing what? Lots of black, yeah, shoot will be absolutely there. Now incomplete combustion, so they are exactly reflexive of what? Incomplete combustion. They are exactly reflexive of what? Incomplete combustion. And even saturated hydrocarbon gives shooty flames. Sometimes saturated hydrocarbons are also giving shooty flames. That is thing. Now LPG stove at home, I'm just talking about LPG stove at home, have inlet air that provides sufficient oxygen. Okay. Now I just want to know one thing. So when it will not burn, but when the air in the holes will be blocked, will it give you a clean flame? See, LPG, that is liquefied petroleum gas. Understood? It is butane. And you need to understand one thing. I'm going to ask the question again one more time, children. Just go for it. Try and understand this part. The question what I'm asking here is, ki if, just learn it. If if the nozzle of the what you call LPG in this gas cylinder, if the nozzle will get choked with some dust particles or some what you call, you might have seen the nozzles are very free. So if the nozzles will not be free, it will be it is exactly getting some dust particle. Will it burn with a clean flame? Though it is what you call, it is sufficient, it need less amount of oxygen, sufficient amount of oxygen also it will be burning. Will it? No, it will not be burned with a clean flame. It will not give you a blue color flame. It will exactly show some yellow color strains with black color contents. So that's it. Is exactly, this is the reflection, or this is exactly indicating that, this is indicating a very important point, and that indication is about that it's giving an incomplete combustion because oxygen supply is not adequate. Understood? The oxygen supply for burning is not adequate. So what we need to do? We need to clean up the nozzle so that wastage of gas or wastage of energy should not be there. Okay, the fuel will not be burned completely. And it will exactly, one more example we can say there, that whatever vessels or whatever utensils we are using at that case for cooking, that will exactly get black, what you call, black ashes, it will exactly get. So that's also one thing that is exactly representing. Now why do substance burn with or without flame? Why do, I'm just asking you this question. Yes, so why do substance, I want everyone to type and say, I want to everyone to type and send this answer. Why do why do substances burn with or without flame? Substances burn with or without flame. Why do substances burn with or without flame? Mm, Anushri, that's very near. Seriously, boss. Nice. That's very near. I'm just reading your comments only. Lack of O2. Think one more time. Lack of O2. One more time, think. No, I am going with because presence of O2. With or without flame means presence of O2 is not the answer. See, that's what in science exam now. In science exam, when you will be writing, that time your presence of mind, how you are interacting, and how you are answering the question. That's also force of attraction. Force of attraction. Force of attraction. Hey, maybe since it has something gaseous so that it vaporizes and flame goes. Very near, very near, very near. So I'm just exactly experiencing like fine, you are going very near to the content, but really I need lots more, little bit more. Coal, yes, it is very much related to burning of lac. See, I'm going to explain this one out. See, when you burn coal and when you burn charcoal, so vaporize them combustion occurs. Yes, see, you have this concept. I'm not saying that you people are not having the concept. Actually, you people are having the concept. But the most important thing here is, thank you for liking the class. But the most important thing here is कि you are unable to capitalize it. Substance burned with a flame when they are volatile and turn into gas. Yes, that's true. And before or during combustion, and without a flame when they do not vaporize and the reaction occur in the solid. Yes, absolutely correct. So that's what is most important thing. But we are going to understand in the most accurate way. Are you all ready? Are you all ready, children? Now, please kindly pay attention here and try to understand this part. See, I'm going to take coal and I'm going to take charcoal. Okay. So, what is the difference between coal and charcoal? Coal is having volatile substances in it, okay, because we know that it's exactly the residue, okay. So, coal means fossil, sorry, it's exactly the fossil which was exactly deep buried inside the earth for long time. Got it? So, when we are taking it out and we are burning it, it is combustible. But the most important thing here is, so for 2 minutes I'm not reading the comments, I'm just explaining. After that I'll read the comments, okay. So here what is exactly happening is कि when coal will be burned, the volatile substances that is present in the coal will be exactly burned, and these volatile substances will produce what? They will be producing smoke, dust, ashes will be there, understood, and it will burn with a flame. It will burn with a flame. Now, this coal will be exactly what we are going to do is we will take the coal and we will do its destructive distillation. What is the meaning of destructive distillation? Destructive distillation is a process where we will be taking out the volatile substances from the coal and we will be exactly going to make it another substance. Understood? So, coal will become what? Because charcoal is wood. Wood is exactly going to give charcoal. Then coal is going to give coke. Understood. So here, yes. So when you will be burning coal in absence, see, it is exactly burning. We are not giving a direct burn. We are burning it in absence of oxygen. Understood. So in a chamber, we are burning the coal, and we are why? Because we are going to take out all the volatile substances of it. So once the volatile substances of the coal will come out, the coal will become perforated. Means some holes will be generated in that, and after that it is exactly going to get converted into coke. Now when this coke or wood will give you charcoal, so wood also if you will burn in absence of oxygen, the process is called as destructive distillation. At that particular moment what will happen? At that moment what you are getting as a product is, when wood will be burned, charcoal will be formed, coal will be burned, coke will be formed. So when you are making this solid substances, after using the word after using the process of destructive distillation, now they are 100% combustible with a very high amount of heat and light. Understood? So here flame will not be generated. but they will give you a complete combustion. So heat generation will be what you call, see, heat generation will be high. Heat generation will be very very high. I hope you might have understood this one. Come on, say. I hope you got this point, beta. Heat generation is very very high. I hope everybody understood. I hope everyone understood. Got it. Thank you so much. So here it is very, very important to understand that yes, heat generation will be high. Absolutely. Absolutely. Heat generation will be high. So we need to understand this. I hope everybody understood this one. So heat generation will be very, very high. Just 1 minute. Hello. Hello. Anna, no, he did not reply. Hi, Anna, get ready. 9 o'clock will start. Yes, used to produce electricity. Yes, we need to understand that when we will be exactly, so used to produce electricity. What is used to produce electricity? Coal is used to produce electricity. Yeah, so volatile substances will be out. Once the volatile substances will be out, the vaporization will not be done, and it is exactly going to give a complete combustion. Complete combustion with will not produce flame. Understood? Without flame, complete combustion. Without flame, complete combustion will be there. Heat generation, the amount of heat generation will be quite high in compared to that of using coal or what you call using wood. I hope you might have understood this one. So yes, sooty flames will not be generated at that case. Sooty flames will not be generated at that case. Now, one question I am asking, answered. So when the atoms of, listen the question, when the atoms of gaseous substances are heated, listen very carefully. When the atoms of gaseous substances, when the atoms of gaseous substances are heated, which type of flame is seen? Luminous or non-luminous? When the atoms of gaseous substances are heated, when the atoms of gaseous substances are heated, I'm repeating, when the atoms of gaseous substances are heated, which type of flame is seen? When the atoms of gaseous substances are heated, which type of flame is seen? The correct answer is luminous. Absolutely. So we have learned another important point कि when any, yes, atoms of gaseous substances will burn, it will always be producing luminous flame. Understood? Now, color of the flame will be produced depends upon the element which is burned. That's another important point. So we are exactly triggering a very important point, that the color of the flame, which type of the color, sometimes you might be seeing that something is burning, it will produce green color flame. Something will be burning, it will be producing red color flame, which is quite uncommon now, because we are very habituated with blue color and yellow color. When blue color we are seeing means complete combustion, yellow color we are seeing means incomplete complete combustion. But here when other colors like green color will be seen, red color will be seen, that is quite unnatural. So that time what we are considering it as, yes, that time what we are, it is producing, it depends upon the element. It totally depends upon the element, because the color produced by the element is the characteristic property of that element. Because the color produced by the element is the characteristic property of the element. Please note down this one. The color produced by the element is the characteristic property of the element. The color produced by the element is, yes, brown nitrogen gas. Absolutely, beta. So here, please, I repeat the thing. See, when the elements, atoms are burning, so atoms of the elements or the compounds are burning, they will be exactly producing what? They will be exactly producing luminous flame. Now this luminous flame will have specific color because of the characteristic property of the element. Because of what? Because of the, yes, it totally depends upon the element, or we can say because of the characteristic property of the element. Because of what? Because of the characteristic property of the element. I hope it got into your brain. It got into your brain because of what? Because of the characteristic property of the element. Luminous, exactly, luminous flame is formed. Now, formation of coal and petroleum. You know that coal and petroleum are exactly what? They are the fossil fuels. The coal and petroleums are what? Fossil fuels. So just one time I'm discussing coal and petroleum are what, beta? Fossil fuels. I'm reading your comments and I'm speaking also. Okay. So these substances will be exactly formed from biomass. Biomass. What is the meaning of biomass? By different biological, chemical, and physical process. First, though, we were not be able to make synthetic coal and other things. Now we can be able to make coal things in the lab, but the thing here is biomass means the residue. We can also say that the residue of plant and animal, if it is exactly kept under certain temperature for a prolonged time period, and oxygen supply should not be there, then only these fossils will be formed. Oxygen supply should not be there, then only these fossils will be formed. So that's why it is by different so the chemical process will be there, yes, physical process will be there at the time of formation. So coal is the remain of what? If somebody will ask you what is the how coal is formed, come on, say, genius fellows, say how coal is formed. Come on, I want everyone to answer how coal is formed. Check your live or not, your answers are coming very slow. How coal is formed? Come on, say. Under high pressure, but what is exactly the residue which made coal? सूजो गुरु, सोजू गुरु, नहीं, नहीं पहचाना. Now look here, नहीं, ऐसा नहीं है. How coal is formed, I'm asking. You are exactly talking about wood in presence of oxygen, no? फिर तो बढ़िया. उल्टा पुल्टा मत लिखना प्लीज, बच्चे हैं. Wood is burned under high pressure. No, see, coal formation is exactly millions of years has been taken to form coal. So we can say that due to some earthquake or some volcanic eruption, what is exactly happened? So due to some earthquake or some volcanic eruptions, what happened for what you call that the plants, the trees, they exactly got buried under the earth, under very what you call, they got buried under earth, and a layer will be generated, the layer of soil will be generated over them. And because of that, like, see, the plants and the trees what was present on the surface, these trees, what happened, these trees, because of some volcanic eruption or earthquake, these trees got buried under, so these trees contents were there, they got buried under soil. Understood? The soil layer, these trees and plant got buried under soil, and in that, हाँ, वो सही है. So now look here. So beta, these the soil will be exactly going to the soil is going to cover it with a high what you call, and a very high pressure will be generated. So here when the soil is exactly going to cover the plant and animal plants, specifically I'm talking about plants and trees. So when they are exactly going to bury them for a long period of time, so here oxygen supply is cut. Understood? Oxygen supply is not there, and exactly the fossils will be of under high pressure. So add, because of this, it will be exactly getting converted into coal during long time gap. So understood? So maybe some dense forest might have been there. Yes, maybe some long, what do you call, maybe some long, like dense forest might have been there long years ago, long time before, millions of years ago, we can say. Dense forest might have been there. And this dense forest, yes, low level of oxygen, supply of oxygen cut. And when the supply of oxygen is cut, after that, what happened is exactly whatever plants and animals, plants specifically I'm telling, it went inside, it got converted into coal because of high pressure and temperature, deep, getting deep buried inside the earth surface. Okay, and oxygen supply was not there. Yes, but what about the oil and the gases? See, the oil and the gases what we are getting, extracting, it is supposed that whatever animals were present in the sea, they got buried under, they got buried under for long period of time. Okay. Yes, I'm playing chess. So now listen. So here, long period of time, they will be exactly the plant and animals which were deep buried inside the earth for long period of time. They will be, see, animals specifically, they will be getting converted into oil. Understood? The crude oil what we are getting from the seabeds, that will be exactly obtained from there, huh? From the seabeds, yes, mostly from the seabeds, what the crude oil we are getting, that will be the exactly the content or the remains of, yes, non renewable, they are the remains. 2000 तक कह रहे. So I hope you might have understood this one. So now we are going to go for the next part. So this we have this, so due to high pressure, they will slowly compressed into the rocks and steeped into the porous part of the rock. Okay. And once they will be steeped into the porous part of the rock, they got trapped in the water, and they will be exactly making water in sponge, and they will be exactly getting converted into oil. Huh? 'No, मुझे नहीं पता. So now we are going to talk about oxidation. Are we ready for studying oxidation, children? So now let's talk about oxidation. Are you ready for oxidation? Okay. Ready for oxidation? Come on, say. Yes. So when we talk about oxygen, so when we addition of oxygen to a compound in an example of oxidation. So when we are adding oxygen to a compound, it is considered as oxygen. See, notes will be available because I'm just explaining the thing. The proper notes will be available to you. Okay. So addition of oxygen to a compound. So any compound we will take which will be combustible. So what will happen? Oxygen will be added to it. Understood? And this addition of oxygen is nothing but combustion only. Okay. So now just check this one out. CH3, CH2OH is there. Come on. So this is what, beta? Can you say the name of it? Hey, I'm not playing to that level. होम में खेलना और वहां पे खेलने में फर्क होता है. CH3, CH2OH is there. Can you say the name? Ethanol. Absolutely. So when ethanol will be burned, when ethanol will be burned, okay, now we are burning ethanol. Note down this one. Alkaline KMNO4 plus heat. Understood. So what it is exactly going to do? It is going to make CH3 COOH. And this is what? Addition of oxygen. This is what? हीट का सिंबल, तो हीट लिख दिया ना. हीट का सिंबल होता क्या है? हीट का सिंबल हो गया. चलो. So here you need to understand this one. Please understand this thing. कि when we are talking about, yes, CH3COH, that is called as addition of oxygen. So when we are adding oxygen, it is considered as what? When we are adding oxygen, It is called as oxidation. When we are adding oxygen, it is considered as what? Oxidation. Addition of oxygen is considered as oxidation. Or we can say, we will take two things. Either we can say take alkaline KMNO4 and heat, or we will take acidified K2Cr2O7 as a catalyst we are taking. So acidified K2Cr2O7 पोटेशियम डाइक्रोमेट प्लस ले हीट का सिंबल दे दिया. So they are exactly helping for oxidation. They are the things that is, or catalyst, what you can say, they will be helping for oxidation without actually involving in the reaction. So I want to say about catalysts. The catalysts are those substances which will exactly either increase the rate of reaction or decrease the rate of reaction. Means they help in the proceeding of the reaction, or they can help the reactions to get little bit slow down. So they are exactly called as catalysts. So catalysts are those substances which are capable of, what you call, which are capable, thank you for liking the class, which are capable of making the reaction proceed further without actually involving in the reaction. Without actually involving in the reaction, make the reaction fast or slow. That's the exactly work of a catalyst. Oh, come on, that's the work of a catalyst. But one thing you must remember here, please understand this part. So when we will be talking about catalyst, see, catalyst can increase the rate of reaction and catalyst can decrease the rate of reaction, but the reaction can be proceeded not only by catalyst. Some catalysts are there which will be helping, but all the reactions do not need catalyst. Some reactions will be some reactions will be spontaneous. Without any help of catalyst also it can proceed. Understood. So this is exactly something which is very, very important. I hope you might have understood, everybody. So please check this one out. So in this reaction, what we have used two things for oxidation. First one, what we have used for oxidation is KMNO4, that is what you call alkaline KMNO4, or acidified as an oxidizing agent. We can say them as oxidizing agent. So combustion is also example of oxidation reaction. Yes, combustion, it's nothing but combustion only. So we can say that combustion is also an example of what? Oxidation reaction. Combustion is also an example of what? Oxidation reaction. This is much to remember. I hope you might have understood this one. So high reaction metals can react without the presence of catalyst. Yeah, so when we talk about sodium and potassium, do they need any catalyst? No, they don't need any catalyst. Exactly, correct now. So they will not be needing any catalyst there. So in the absence of catalyst, they are exactly showing reaction. In the absence of catalyst, they are showing the reactions. They are doing the reactions, sorry. They are doing the reactions. So they are exactly something we must understand in these sections. Okay. So these are called as oxidizing agent. Who and all are the oxidizing agent? I have told two oxidizing agent. One oxidizing agent is alkaline KMNO4. Understood? Second is, that is potassium permanganate, and second is potassium dichromate. Okay, K2Cr2O7 and KMNO4. So these are the two oxidizing agent which will be added so that they will be actually able to do oxidation. So what is oxidation? Combustion is also an example of oxidation. I hope everybody understood. Come on, say fast. Till here, everybody understood? Oxidation is a type of combustion only. Oxidation is a type of combustion. Is it okay, children? Yes, version. Super. So notes will be available as fast. If the once I'll be getting it, I'll be providing you the notes.